All right, so once more, good evening, everybody, and it's good to have you all on the call. I'll do a quick recap of what we have discussed over the past two classes. I think we've had two live sessions where we discussed the computational techniques in data science. And for those, if there's anyone that is new on this call, let's say today's your first day joining my class because you heard about the test you'll be having tomorrow, welcome. Um, I'll quickly give you a rundown of how this class has been structured. We meet every Thursdays and Fridays, but I think we've skipped one or two meetings. Um, we've met two times or three times on Fridays. So Friday we meet physically in the school, while on Thursdays we meet online like this 8 p.m. So when we meet physically, we focus on the mathematical techniques. We solve the mathematics behind data science and data science structures, while on Thursdays like this, we discuss the computational techniques. That's why you can see, all you can see on my screen is a Jupyter notebook. So we have done justice to the first few sections of this notebook. We've looked at Python basics, we've looked at NumPy, we discussed vectors in Python, and everybody on this call is able to present vectors. We've also discussed num and distance. So as I'm going through this, I'll just be running the cells so that I don't have to come back to them again. Yeah, so we've looked at NumPy, and I also have introduced us to the data set we're working with, that is the Penguin data set, and we're able to look at the dimensions of any vector we have. We can pick the elements, different elements in vectors, and we also did calculation of dot products using the Python's notation as well as the NumPy formula for dot product. And we also covered Euclidean norm and distance. We calculated Euclidean norm and distance, and we also looked at distance between 2 points. Very important that you know all of these concepts. Yes, so today I will be introducing us quickly to visualization in Python. We'll be running our visualization using Matplotlib. Matplotlib. That's what we're going to use to visualize data points. Before you start any visualization, I think I have imported the library somewhere at the top. Yes, this is where the library was imported. We imported matplotlib.py plots as PLT. There are different, I think I am very proficient with about 3 Python visualization libraries: matplotlib, Seaborn, and plotly. So I use those three for visualization. They are very nice to packages in Python. So, but throughout this class, our focus will be using Matplotlib. So, if you want to visualize your data points, data sets in Python using Python, all you need to do is to start by importing Matplotlib as PLT. That is the alias. Matplotlib as PLT. So as seen on my screen, we imported NumPy as MP. Now we're importing Matplotlib as PLT. So every other settings that we have done here is just it's not compulsory for us to do it for the visualizations to pop up. But of course, to have it inline, even if you don't do that, because this Jupyter notebook is going to pop up, your matplotlib will pop up, but this line makes it appear directly inside the notebook. And we have this for the nice styling. Just use the RC params and the size and the DPIs. Again, like I said, even if you don't put these parameters, define them here, your chart will still run very well. So this is just to check the version of NumPy we have. We're using version 2.3.5. The most important thing in all of these cells that I've written is just this one, importing your matplotlib. So that's that about importing matplotlib. But this is where we start, where I want to explain visualization in Python right here. Okay, good, here. So this is how we start visualizing data points. Okay, I have so what do you want to visualize? That's the question. So what we're about visualizing, somebody's mic is unmuted. Do you have a question for me?
So sorry. Please, are you recording the class?
Yes, it's being recorded.
Okay, thank you.
You're welcome. So what we're about visualizing is the data point we have for the two penguins. I know that we all have this Jupyter notebook because I've shared this it's on my website, and I've asked that everybody download it. So I just assume that we've been going through it and we familiarize ourselves with it. So we're trying to visualize data points. We just took the measurements of two penguins. Where do I have that measurement? Give me a minute. Let me locate where we took the measurement of the two penguins. Okay, this is it here. This is it here. So we took measurement of two penguins, specified specified to 2D for clarity, just in 2D. Penguin A has the Coleman length of 39.1 and the flipper length of 181.0. Penguin B has the same Coleman length of 46.5 and the flipper length of 215.0. All right, so we went ahead to calculate the difference. We compute the difference vector, that is, what is vector? Of course, the measurement of penguin A forms a vector in two-dimensional space, and the measurement of penguin B also forms another vector in two-dimensional space. We took the difference of those vectors, and that gave us the difference. With the difference, we were able to calculate the norm, right? The norm. So the norm is simply the distance between penguin A and penguin B. This is it here. If I wrote that distance between penguin A and B, we give us the norm of the difference. This is exactly what happened here. And now we were also able to use that norm to calculate the squared distance. And that gave us this result here. So the square distance is 34.7960. All right, so that is the squared distance, which is also equivalent to the norm of the difference of those two vectors. Now, this, what we've just done here, I want us to see it I want to visualize it so you can see it on a graph so that you understand what has just happened here. That is the reason why we're introducing us to visualization. So the first thing I did here was to just define these two parameters, fig and ax. Ax stands for the axis, fig stands for figure. So I would like to have these two parameters as subplots, and then I gave a dimension of the subplot 6,5. This is just, this value can change. This is the width and the height. 6 is the width, 5 is the height of the figure that we're going to produce at the end of the day. Now we are plotting the 2 points. Don't forget the first point is what? Let me display the first point. So the first point is what we call penguin underscore A. When I display penguin underscore A, this is the point 39.1 and 181.0. Then the second point is penguin underscore B. This is the second point. So when you display these 2 points, this is how it's being displayed. Okay. Well, most of the parameters here are not needed. Even if you don't put them there, everything will work very well. If I just put the scatter of A and scatter of B. So what I mean is this: if I pick this one, axis A, okay, let me break this particular codes into different cells so that we understand how to break it down for clarity. So I'm going to call this fig underscore axis. Okay, this one is giving me an empty axis now. So in this empty axis that I've created, if I plot this particular first point here, if I plot the first point and take out all these parameters without any other additional parameter, I can see this is point A. You see, when you trace this point A, this A axis scatter of penguin A, when you trace it down, you notice that on the x-axis is 39.1. Look at this point. On the x-axis, 39.1, while on the y-axis is 181. When you look at it very well, you see that's what gave us that point. Then if I bring this other one for point B, if I add this scatter for point B here, and then include my brackets, oh, sorry, I omitted B. B, close the bracket, then you would see this is now A. A is at this point, 39.1 and 81 and 181. Then B is somewhere up here, 40. I think B gave us 40 what? 46.5. Yeah, 46.5 and 215. Do you see that? So this is just these 2 points are asterisk A. This asterisk actually helps us to unpack the points in A and B. The asterisk here helps us unpack the points. So it's just this scatter of A and scatter of B. All right. And that's exactly what gives us this dot and this dot. So, but the reason why we have to put why I have to put every other parameters here is so that I can give a color. All right. So even if I don't give a color, there's a default color that Python gave for a blue, and the other one is orange. So this is a color. I want to use steel blue. Then S equals 120. Z order is 5. Label is what? Penguin A. So those are just additional parameters. So that means just these two lines here will help us achieve the points A and B on a plane as seen here. But this other line will help us draw a line that connects A and B, like a line that connects A and B, straight line. This is the code that does that for us. That is axis.plot. So axis.scatter, we give you dots. All right. But axis.plot, we give you different what is it called? We give you a line, connecting a line from A naught, A of 0, B of 0, A of 1, B of 1, and then we want the line to be broken. That's why I put this K dash dash for broken line, and I want the width of the line to be 1.5, and then it's going to have a distribution that's equal to approximately equal to the distance. That's going to be the label. So on the label, on the line, you will see a label that would have this, not distribution, distance equal to this. So when we run the code, you will see a label on the line. And then here is just to annotate the points A and annotate the point B, so that on these points A and B, you will see an annotation that shows you the coordinate of A as well as the coordinate of B. Then, of course, this is just to set the Y and the X label with the title of the chart. So when I execute this code, this is exactly what we just have, right? So you can see that this particular chart is more informative compared to this. This is just blank, nothing there, just the points, because we didn't add all of this other information. But adding those had given us a chart title, the Euclidean distance between 2 points. It gave us the Y. I see your hand. I'll take a question. Just give me a minute, please. It gave us the Y-axis title, flipper length in millimeters. It gave us the X-axis title, Coleman length in millimeters. And it gave us the connection between points A and B with the, what is it called now? With the label, the coordinate of B, the coordinate of A, and it gave us this legend, AB, and then the distance, which is 34.80. So that is how to plot and add a lot of information in your plot. Yes, let me take the question now. Please go ahead with your question, Mr. Samuel.
Are you with me, sir?
Mr. Samuel,
yeah, are you with me, sir?
Please. Yes, please.
Can you go the graph? The point to show. Can you go before this graph?
Here.
No, before the graph. No, not this one. Before that, this one. Yeah, I'm good. Yeah. Now this X for axis scatter penguin A.
Yeah.
This S equals 120.
Mm-hmm.
That S equals 120, and
Yes.
the border equals 5.
Yes.
How did you come about the 120, sir?
Okay, so the 120 and the 5, these are just parameters that are given to how you want your chart to look like. It is a number that can change. You can put any number that you want there. I can change this one to 80 and this one to 80. Then I say let this be 3 and this be 3. When I execute it, it will also give us a chart. Do you see? Now, but you will not even notice the difference so much of these two values. In fact, if I take them off, let me take them off for now. I'll cut this, Control X to cut it, and then take this one out. Then if I execute it, our chart is still displayed. Do you see that? So those are just additional parameters. Go ahead, please.
Because the reason why I asked is I wanted to know what is that X, what does it stand for? What is the role on the chart?
The role. Okay.
The role of that S.
Let me show something. That's a good question. So you see can you see what just popped up here? What popped up?
Yeah.
All right. So what popped up here is these are different functions that can be added to a chart, right? So when you are creating a chart, for each type of charts that can be created with under PLT, there are different attributes that can be added for different types of charts. We have scatter plot as a type of chart for PLT. We have plot as a type of chart for PLT. And in fact, wait, let me just quickly do a quick browse so that we will see the different attributes here. Scatter plots in PLT attributes. Just hold on. I'm still going to answer your question. I just want to share something. Okay, good. So these are the attributes. Fantastic. Can you see that there are a lot of attributes now? You see X, Y. This is data sets, the data position for the horizontal and the vertical axis. S, that S you saw there, is the set the size of the markers in points squared. Do you understand? The size of the markers. This marker we have here, this dot and this dot, right? That is what is set here, this dot and this dot. That is what S represents. It's set in point squared. This can be a single value or an array matching the data length to vary size of points. Somebody's background is noisy. Is your background, Mr. Samuel?
Yeah, that should be my.
Okay, you can mute yourself while I speak. If you want to speak, you unmute your mic. Then there is another parameter that I didn't add under attribute C. C sets the color of the markers. I think we added C. Yeah, we added C. This is C. Okay, you can say C or color. It sets the color of the markers. Then there's another attribute called marker. Marker specifies the shape of the data points. You want it to be circle, or you want it to be asterisk, or you want it to be S for squared. There's another attribute called alpha. There's another one called C map. There's another one called edge, and so on and so forth. So this C here is just an attribute that tells us what is going to be the size of the marker, this marker that we have here. That is what it does. So whether you have it or not, your chart will still work just fine. So we added it there for the shape of the what's it called now, marker that we have. So what did I take out? I think I didn't add my comma. That's why we're having the error. Add a comma here, another comma here. So I hope I was able to answer your question, sir. Where did I miss out again?
Yes, sir.
Okay. Did I miss out any comma? Where's my invalid syntax label? Oh, sorry, I said S equal to, so that S is not supposed to be here. All right, so any other questions, please? Any other questions from anyone? Okay, so this is, we have successfully created a chart, right? Created a chart or plotted a graph to represent the two penguins. So these are just two penguins, and again, it's just in 2 dimensions. If the penguins were more than 2, as we had about so many of them, right? Then you should notice that We will not have only 2 points like this point, point. Yeah, someone's mic is unmuted.
Mm.
Mr. David, do you have a question for me? Mr.
Yes,
David,
sir. I don't understand, sir. Yes, sir.
please go ahead.
From the graph, sir, I don't understand. So my network was having issue then.
Okay. So when you say from the graph, I need to understand what point exactly you're referring to. Mr. David, can you hear me?
Yes, I can hear you now.
So I said when you say from the graph, I need to understand what point you're referring to.
As in before I joined, so I
Yes.
have a network issue. I joined late, so I
Ah,
couldn't catch
okay.
up.
Okay, I see. All right. Let me just do a very basic, let me create a very basic chart here. A very basic chart that would help us understand this scatter plot and the likes. So I said that when you want to create a plot, the first thing you do is to import matplotlib matplotlib dot plt as no dot pyplot rather pyplot as plt. We've done that already at the top, so I don't have to import it again twice. All right, we've already imported matplotlib as plt. All right, so I'm not going to import it again, but if you're going to create a chart, that's the first step to be taken. Okay, so once you import matplotlib, then you can, as plt, then you can create any chart. So when you type plt dot and you press tab key, you will see different functions, different types of charts you have. So these are different functions and classes that are attributed to plt. So there is ACORR. I've not used this before, so I can't say so much of the function, what it does. Angle spectrum, annotate. I've used annotate. Annotate allows you to put annotations on your chart. Then annotation is another class. There's annotations, there's arrow to draw an arrow on your chart. So all of this will take you time, will take some time for you to know how they are being used. But what my focus is this evening is to use PLT to plot a bar chart. This bar will plot bar chart. Box will plot box chart for you. We also have box plot. We also have draw. We also have scatter. S for scatter. This is scatter. We also have plots. We have spy. So different types of charts are here. But I'm going to create a very simple chart. I'll create a simple scatter plot with two random points. So let's say we have a point A. No, let me call it, yes, let me call it point A. We have, no, not point A. We have, okay, yeah, point 8. Point underscore A equal to, point A has these numbers: 2, 4, 1, 0, and 5. So how many numbers do we have here? 5 of them. Then point underscore B has, let's say we have 3 minus 1, I have 2, and I have 1 and say 3. All right. So when I say plot plt dot scatter of x equals point A, comma, y equals point B, and I close my brackets. Do you see what just happened here? Can you all see my screen? That is the most simple type of scatter plot you can create in Python. Most simple type. So I have been able to plot a scatter plot of points A and B. Now, this is what Python did. It took 2 and 5, I mean 2 and 3. So 2 on what's it called, x axis, and 3 on y axis. That is the point. 2 on x, 3 on y. Then it took 4 and minus 1. 4 on x, minus 1 on y. It took 1 and 2. 1 on x, 2 on y. It took, what again? It took 0 and 1. 0 on x, 1 on y. It took 5 and 3. 5 on x, 3 on y. Do we understand? Please, do you understand? If you understand, give me thumbs up. So your scatter plot, the most basic plot for scatter, when you're creating a scatter plot, you need 2 points, point A, point B. Then you need to put those 2 points as your x and y coordinates. So if you want to give it a title, you want to give this chart a title, what you need to do is you just say after your scatter plt dot title, plt dot title, you give it a title. Let's call this sample scatter plot. So once you do this sample scatter plot, close up, and then your title will show. Can you see it at the top? Sample scatter plot. That's how to give your chart a title. If you want to give it an x-axis title, you want an x-axis title here. Under this, you just call plt.x label, plt.x label equals plt.x label, open your bracket. Let's call this point, let's call it point A, point underscore B. That's point underscore B. So you close the bracket. When you execute this, you will see your title. Sorry, set plt.set. I was supposed to say plt.set x label. Oh, it's there. Sorry, this is it here. Point B. This is actually my x label is A, not B. Do we see it? This my x label is point A. Then I can also give it y label, plt dot y label. I can call this point underscore B. And then you see your y label, point underscore B. So this is how you can start building up a chart, adding spices to it. So all of these things that I added here, everything here, legend and all, they are just spices that I'm adding to it. The most important part of this chart is these two AX axis scatter and axis scatter. All right, those are the two most important parts. And in the simple example I gave, I just called these two things in one scatter plot. I didn't put them in two different scatter plots, just like I did here. So if I want to do this one, if I want to create this one like this example I gave, it means that the 2 points will just be in a single line like this, and then we'll have our scatter plots here. I don't know if what I said makes sense. Does it make sense, please? Do you want to understand, at least to a large extent, how to create a simple scatter plot using Python, matplotlib? Hello, are we together?
We are together.
Yes, sir.
All right. So that's that about the scatter plots. But here we only plotted for 2 points, and now that will lead us to. So the reason why it's important for you to know matplotlib in Python is because as you are writing your code to perform any form of classification or clustering for the k-means problem that we're trying to solve, there will be times you would need to plot graph to visualize what you're doing or what you're doing, for you to see what you're doing actually. And for k-means, of course, there's no way you won't be visualized, because we need to see the clusters of the various points. So if I increase the data points in this point A and point B, you will see how large it's going to look when we run such a point here. In fact, I think I should do that. I should increase the point so that I can see how many of the points we would have here. We can use rand between or random numpy dot rand int. Let me use a different point A as np dot rand random. Should I do rand between or rand int? np dot random of. Okay, don't worry. Let's just continue with this, and then let me make it complex. Let's just move on. I don't want to make it complex because I've not introduced those functions. I don't want to begin to use them here. Okay, so let's talk about the 5th section, which is the data matrix. So from definition to at least this is we have discussed what data matrix is in our math class, and now we want to go into our data matrix in Python. So the data matrix is any matrix that's expressed as X equals the column vector in R D cross R n cross D, that is n by D dimension. Each row is one data point. We've discussed this intensively in class, and each column is one feature. So this row is a data point. 39.1 and 181, that is the measurement of one of the penguins that we saw earlier, this one. This row is another for measurement for another penguin, 46.5 and 215. At least we saw these measurements here. And this other row is for another penguin, this is for another penguin. Then the column here is a feature. At least this column is a feature that represents the Coleman length. Then the next column is a feature that represents the flipper length of the 4 penguins that we measured. So here n equals 4 penguins and d equals 2 features. If we take more measurement of more features of the penguins, it means that we would have more columns. All right. So in Python, a matrix is just a 2D array, and this is how it's being represented. We represent this matrix in this way. I think we've also seen the representation last week, where X represents the array, X equals np.array. This is the first measurement for penguin 1 in row 0. Penguin 2 is on row 1. Penguin 3 is on row 2, and so on and so forth. And I just want to print this array, and I would like to see it as data matrix X. And I would also like to see the shape. The shape is what is the number of rows and columns in that. And I would like to print out the data points on the N shape and then the dimension. When I execute this cell, you see everything that we've already written in the code. This is data matrix X with the following rows, then is of shape 4, 2. The number of data points n equals 4. The number of features d equals 2. Exactly what you wrote in this place. So this is just to say that whenever you are given a measurement of any number of rows and columns, you can easily express it as a vector space as given here. So are there questions? Any question, please? Any question? All right, so in the absence of questions, I would like to ask a very simple question here, and I want everybody to, you know how we do it now. I'll drop a matrix, and I would like us to give me the Python representation, NumPy representation of the matrix. So I'll do that right away. I'll add a new cell here, but this cell I like it to be a markdown, and I'll enter the code, and let me do this. What should I do? So I'm going to do this, and 2, 1, 2, and 1, 1, 3, and this, and this, and this, and this, and this, and this. Let me do this, this, and this, and this, and this. All right. So I would like us to express this matrix. Write the code, the NP array of the representation of this matrix. So everybody, please, I'd like us to put all hands to be on deck. Once you write the code, drop it in the chat here. I would copy the code and execute it. Let's see the person that will give us the correct representation of this matrix. I'd like us to represent this matrix using NumPy array. This is what is the dimension of this matrix? Please drop the answer in the chat. That is my first question now. What is the dimension of the matrix presented on my screen? I think I should just call it matrix Y since I've used X before. Let me call it matrix Y. So what's the dimension of matrix Y in the chat? Or who wants to just unmute their mic and tell me? Yes,
Okay.
anyone?
Yes, I think it's a 5 by 4 matrix.
Are you sure?
Yes, sir.
5 by
Yes,
4?
5 by 4. Yes.
Beautiful, that's correct. So it's a 5 by 4. Sir Idris, it's not 4 by 5, it's a 5 by 4. So you count the number of rows. 1, 2, 3, 4, 5. 5
4 by
rows.
4.
1, 2, 3, 4. 4 columns. So it's always number of rows by number of columns. So it's a 5 by 4 matrix. Now I'd like us to drop the answer, the NumPy representation of this matrix. Please drop it in the chat very quickly before we proceed. The NumPy representation of the matrix. So I'll give us, because I know that this might take us some time to type. So I'll give us about 3 minutes to type it. I'll start my timer now. Once it is 3 minutes, I'll stop everyone, and then let's see the answer. So 3 minutes, 3 piece, and the timer is counting down. Just look at this. I just want to stay here so that everybody can see the matrix. So keep your eye on this tab. You can see it's counting down. This is 2 minutes 54 seconds now. All right. I expect everybody to respond to this, please. Thank you very much. I'm waiting for your answers. All right, ladies and gentlemen, thank you for attempting. It's time up already. Let me see your answers. Okay. Mr. Abdul just sent me import numbers MP. Is that what I wanted to to see. Nope. Okay, let me see Mr. Umar's own. Fantastic. He went ahead to I'll copy Mr. Umar's code. Yes, please go ahead. Samsudin, go ahead. Your hand is up. Go ahead with the question. If you're speaking, I can't hear you, sir. So this is Mr. Umar's answer. I will execute this now. Wow, this is interesting. So everything looks very good. Thank you very much, Mr. Umar. And yeah, thank you. And I think he's the only one that had sent in his answer. What happened? What happened with others? Out of 21 people on this call, or 22 people on this call, still one person that dropped an answer for me. What's happening? Are we good? Or is anybody sleeping in my class? Okay, Nathaniel just dropped his answer. Okay, I'll copy Mr. Nathaniel's phone right now and execute it also in a new cell. Okay, he didn't, let me just call it Y Nathaniel. No, excuse me, he didn't print it. Let me print it now. Why not? So this is why not, and that's also correct. I'll call this Y. Who sent this? Umar, right? I'll call that Y underscore Umar. Please go ahead with your question. I can see your hand up.
No, I'm done with mine, sir.
Okay, so I'm changing everything to Y underscore Umar so that don't overwrite each person's response. Good. So that's Mr. Umar's own. Smart. Let me see who else dropped in an answer. That is Samsudin. Okay. Mr. Samuel, do you want to send in your answer in the chat or?
Okay, let me send my answer in the chat.
Yes, please.
Or
Oh,
I should, is it to share my screen or send my answer in the
Sam.
chat?
You can just send it to the chat.
Okay.
Why Sam? Okay. Yes, this is also correct. This is also correct. All right. So once I get your own, Mr. Samuel, we will continue. So the reason why I do this, what I'm doing is very intentional, right? When you see a code on my screen, when I explain the code and I write the code, it will look very simple. It will look very simple, and you feel you understand it. But when it's time for you to execute yours or write your own code, you begin to see have different errors, and the error will just be because of one very tiny thing. So the only way to learn coding is to write code, right? So that is the reason why I'm intentionally asking us to do this on the call. Yes, so please let's try as much as we can to participate during the class so that we can understand what we're doing. All right, so I think I'll go ahead. I'll continue the class. All right, I can see Mr. Abdulaziz. Well done. I see yours. Well done. And I think it looks correct. Good. So let's continue. Now we've all have seen how to represent higher dimension matrix. Of course, this is a matrix, and we've represented those matrices as mp.array. That's how to represent matrices in Python. We can also access rows and columns. I think we did this a little bit last week. We can also access rows and columns. So to access the first row in our Penguin data, we just say x of 0. So x of 0, x in a square bracket 0 gives us the first row, and then x in a bracket 2 gives us the third row, and so on and so forth. So when I execute this code, you see that we've accessed the first row of our Penguin dataset with the 2 columns. Then we access the third row using just x of 2. Then we access all the column length. That is column 0. To access column 0, this is what we do. We just say x from full column, comma, 0. This will give you the column. That is, this full column means everything in the row and give me the first column. So that will give us the first, this is the first column, 39.1, 46.5, 38.9, and 49.0. That's this particular, this is here, this particular data set, this is the column. And that's how to access the column, the first column, and the second column just call 1, and that's it. All right. So let's just practice how to access columns, or how to access different data points, or a subset of a matrix, by slicing it using this slicer method. All right. So next, let's quickly move on to the sample mean. That is the centroid. We discussed this in one of the classes we had. How do we calculate sample mean here? It's very simple. In the mathematics class that we had, we said already that when you have the set of points S, which is given in a bracket x1 up to xm, the centroid, which is the sample mean, is calculated using the formula, the standard mean or average formula that we are used to before now, x bar subscript S. This is saying that this is the sample mean, the mean of the sample given. Of course, here is the sample with the data points x1 to xm, and that's equal to 1 over the cardinality of S. The cardinality of S simply means the number of data points in S times the summation of x over all the data points x in S, and that's equal to the summation x1 plus x2 up to xn over m, and that's the average, right? So, and we also have seen the key theorem from our lecture notes, that the centroid xs of S is the point that minimizes the sum of squared distances to all points in S. That is, x bar of S is equal to the arg of the minimum of summation x, the norm of x minus c all squared. Yeah, I think we have discussed this, and this is why the update step of k-means replaces each centroid with the mean of its centroid, or of its cluster. For those that were in the class we had, the physical class we had the last time, I tried my best to explain that k-means algorithm, and in the k-means algorithm we had an update step. Remember, we started with the assumption that we pick an arbitrary point in a cluster. When we pick the arbitrary point, we will then calculate the mean of the different centers or clusters that we've picked. So those arbitrary points from those clusters will then be replaced with the mean. That's the update step that happens in the algorithm. So, and why that happens, or why that is done that way, is because it is the sample mean, or the centroid, minimizes the sum of squared distance. So what does it, let me break this down to, let me try as much as possible to break it down for everyone to understand. So what it means is that when you calculate the distance between the mean or the centroid of a cluster, the distance between the centroid and any other data point in that cluster, that distance is usually very, very short. When you take the sum of the squared of those distances, it is usually the minimum distance compared to the sum of the squared of the distances of those data points in the cluster with any other one. I think I'm just speaking too much grammar here. Let me try to visualize. We're going to visualize it. We'll do it here, but before we do that, let me use let me just write something on my screen so that I can most best explain this whole idea of what I'm talking about quickly. So I'm going to share a whiteboard now, and I hope that I will be able to explain this better when I do. And if you still do not understand, As I was speaking, I know some people are just saying, what is this man saying? Just speaking so much grammar. I don't even understand what he's saying. That's why I want to do this, what I'm going to do. So please, if you can see my white screen, give me thumbs up. I'm showing a white screen now. If you can see a white screen, give me thumbs up. Okay, good. So let me use this white screen to attempt to explain what I mean. Look at this. Look at what I'm talking about. Let's say a we have a set like this with data points. These. So all these are data points, right? These are data points. Now I'm saying that suppose we have the mean. This blue here happens to be the mean. Okay. If I calculate the distance of the mean from this point to this point, this point, this point, this point, this point, this point, this point. You see what's happening here? This point, this point, this point, this point, this point. So when you calculate all these points, W, C, S, S within cluster sum of square, the distances from this mean to every data point, it is always the smallest. Now I have forgotten how to spell small. God, now wow, it's good to go to school. It's always the smallest or the minimum. It's always the smallest or the minimum compared to so compared to what? So let's say I don't want to use the mean. No, so this is the mean here, right? Here's the mean of that is the centroid, the mean. Let's say I don't want to use the mean and I don't want to calculate the distances of other points with the mean. Instead, I want to use these points here as the mean, and I want to calculate the distance of this point to every other point like this. Do we follow? So if I do this and I take the sum of squared of all these distances from this point, which is not the mean, this sum of squared will always be greater than the sum of squared of the mean. That is exactly what I just has been stated here in this notebook. That is exactly what has been stated right here. Please, if you understand what I just said, that's what I said. The centroid x bar of S is the point that minimizes the sum of squared distance to all points in S. Please, if you understand what I just demonstrated with this on my whiteboard, I'd like you to give me a reaction, please. If you understand what I just demonstrated, please give me a reaction. It's good we understand it. It's very important. Hey, no reaction. Hey, my God. My God. Or is it that we are sleeping? I hope nobody is sleeping in my class.
We are not
Don't
sleeping, sir.
Okay. Tomorrow is the test too. And what I'm saying here is very important you understand it too. Mr. Umar, please go ahead. Okay, so I see your this. Mr. Umar, please go ahead. I will answer Mr. Idris. He's not saying anything, or is it his network? Okay, so don't worry, let's just do this thing. Hopefully you will understand by the time we are able to create the visualizations and I explain these two slides, you understand it. Let's do something. Now, I want to compute the centroid. So with this data point we have here, I want to calculate the mean. That's the centroid. So I will cut this, I'll break this into smaller cells so that we understand what I'm going to do. I'll put these points here. So these are points, right? These are point X with two features, 4 penguins and 2 features. The first thing I want to do is I want to first of all calculate the centroid. So let me do this. I'll cut this here. And so here, first of all, I got the shape. That is M, number of points. I got the number of points. I don't even need to do this safe so that it doesn't cause so much confusion. Let me just go ahead and calculate the centroid. So I want to calculate the centroid of the x. Just do x dot mean. That's it. So this is the centroid. Just say x dot mean. That's the centroid. Because all these things here, just story. I'm just writing plenty stories. That's not important. X dot mean will give us the centroid. And either you say x dot mean, or you can do will x dot mean, yeah, or you can do, hold on, let me do something, or you can do mp dot mean of x comma axis equals 0. Okay, so let me see. The centroid is, oh yeah, so the centroid is the point. The centroid is the point that is at the center. Okay. Sorry, it's the centroid I want to calculate. I'm calculating the mean. So the centroid is this, the center point. When I pick all of this one and this plus this plus this plus this 39.1 plus 46.5 plus 38.9 plus 49.0 and divided by 4. Then add this one, 181.0 plus 215.0 plus 188.0 plus 220.0 divided by 4. That will give us the centroid, because the centroid has to be a mean, has to be the center, not just calculating the mean. So that was how we did that with the mp dot mean. All right, so I use two methods to do that. It's either you add up those column wise and divide it by the number of dimension, number of the points, data points, or you just use this simple method. Just use the mp dot mean x axis equals to 0. That will give us the centroid, which is 43.375 comma 201. That is centroid, right? Then we now calculated the sum. So this is a function. This is me writing a function. So I wrote a function that will calculate the sum over all the x points in x minus the center squared. That is, so what I did here is, with the center that I've gotten, 43.375 comma 201, I am subtracting the x's. So this is one of the x. This point here is one of the x, just this guy. This x minus this center, and I'll take the squared of it. Then come to the next one. This x, 46.5 comma 215.0 minus 43.75 comma 201, and take the square of it. Then I come to the next x, this one minus the center, take the square of it. Then this one minus the center, and take the square of that. So that's exactly what I did here in the function. And I will add them up. I started by initializing total to be 0. Use the for loop for x in points, the difference x minus the center, then add that difference to the total just to increment in an incremental form. That is the plus equal to that is happening here. Then return the total. So this is just me defining a function that's going to be used in the future. That is exactly what happened here. All right. And once that function is defined, the function is called sum of squared distances. That function has been applied here, and we printed it. So the sum of squared distances from the centroid is 1,205.71. Okay, and then the sum of squared distances from any other point, another point, is 2,275.27. So you can see that the sum of squared differences from the center is smaller. That is 1,005. 1,205 is smaller than this one. And then the centroid is better because we have this. So Centroid gives the smallest sum of square distances. That is proposition 3.3 that we saw in class. So that is what I tried to explain with the visualization I just showed us. When you pick the centroid and you pick another point, the sum of squared is always going to be the sum of squared difference is always going to be smallest when you do that with the mean. That is exactly what I have just explained. And in visualization form, all this long code is, I'm trying to visualize it. So this is what this code does. I visualized it. Now the centroid is this X, this red star, that is centroid. And we have data points. We have the data point X1, we have X2, we have X3, and we have X4. Those are the data points. Those 4 data points, that is, this one is our X1, this is our X2, this is X3, and this is X4. Those 4 data points is what gave us these 4 points here. And then the centroid is here. You can see the centroid is 43.4 and 201.0. This 43.4 here on the x-axis, then this 201.0 on the y-axis. And when you look at it, the distance from this place to this place squared plus the distance from here to here squared plus distance from here to here squared plus distance from here to here squared will definitely be smaller by taking this one as a centroid. Then you say distance from here to here squared plus from here to here squared plus from here to here squared. So that's not going to be as small as the distance from the center. And that is what will be used for the k-means problem. Any questions so far? Any questions? Mr. Idan is laughing. What's happening? Am I confusing your confusion? Mr. David, your mic came up and then you went off again. Do you have a question for me? The man is on
light on it, sir.
the man is on transit. I
Yes,
should
sir.
see more light again.
Yes, sir. Beg, please.
Okay. I will throw light as much as I can because this light must come. The light must come. Please hold on. I will throw more light. I will throw more light. I will throw more light. So so I will throw more light. And I will take my time to throw the light now because we have to understand this one is very important. So I will take us again to our what's it called, to my whiteboard, so I can explain, because everybody must understand this thing. It's very, very important. Everybody must understand. Everybody must understand. Can you see my whiteboard? If you can see my whiteboard, please give me a reaction. Okay. Now, let me show something. Let me show something. So here is my x, my y-axis, and my x-axis, x, and my y-axis. So I have a point here. Hey, don't disturb me, please. 1, don't disturb me. 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Let's say we have 4 points. 1, silver. 1, 1. Oh, this pen has gone off again. Why doesn't this pen always stay charged? Sorry, I'm with two people. Just hold on. Let me charge my pen a little bit. My pen just went off. This laptop charged at all.
It's charged.
Okay. So I have some points. 1, 1. 1, 1. I have another point 1, 2. I have another point 2, 1. And I have another point, let's call this 3, 2. Don't shake my hand. So let's locate point 1 comma 1. This is point 1 comma 1 here, right? Point 1 comma 2, 1 comma 2 is here. Then point 2 comma 1, 2 comma 1 is here. And point 3 comma 2, 3 comma 2 is here. Okay, so these are 4 points. Are we following so far? Is everybody following so far? If you are following me, give me thumbs up if you are following me so far. So these are 4 points that we've identified on Hello, am I still audible? Hello? Okay, good.
Yes.
So now I will start by calculating the centroid. So how do you calculate the centroid? To calculate the centroid, I would need to add these numbers. To calculate the centroid, I will need to add these numbers here, the x-axis. I will add the x-axis. So these are the x-axis here. What is happening? These are the x-axis here. I will add them together. 1 plus 1 plus 2 plus 3, comma, and divide it by 4. Does anybody knows why I'm dividing by 4? Hello? Does anyone knows why I'm dividing by 4? Please, I need someone to talk to me if you can hear me.
Because you have 4 points.
Good, because you have 4 points. Then, comma, I will then add all these ones on the y-axis. 1 plus 2 plus 1 plus 2. I'll also divide it by 4. So 1 plus 1 is 2. 2 plus 2 is 4. 4 plus 3 is 7. This is 7 over 4, comma. Then this is 6 over 4. So this is the centroid. 7 over 4 in decimal, we give 1.5 something, right? Someone should get me the decimal value of 7. Sorry, 1.75. Then what is 6 over 4 in decimal?
1.5.
1.5.
Yes, sir.
Good. So this is the centroid. We will locate 1.75 and 1.5. So 1.75 will be somewhere around here. 1.5 is somewhere here. So this is the centroid. That is the centroid. That red star. Are we following so far so good? If you are following me up to this point, give me thumbs up. Good. That is centroid. Fantastic. Fantastic. So what we're now saying is that the sum of the sum of the squared sum of squared the sum of the squared or different the sum of the squared difference of the data points from the center is always the smallest. So what I'm saying here is this: if I take the distance from the center to this point, what's the distance? That is, this point is 1 comma 1, right? If I do 1 comma 1 minus 1.75 comma 1.5, then I now take the square of it, yeah, plus the distance to this point here, this one, that is 1 comma 2 minus 1.75 comma 1.5 squared, plus the distance from the center to this point, that is this point, that is 1 2,1 minus 1.75, 1.5, the norm of it, plus the distance from the centroid to this point, that is this one, that is 3,2 minus, no, yes, minus 1.75, 1.5 squared. So this is what is known as sum of squared difference, the sum of squared distance, the sum of squared, the difference between the sum of squared of the data point to the centroid. If you evaluate this, somebody should please help us calculate this. If you can do it very fast. If you calculate all these things here, this minus this squared plus this minus this squared plus this minus this plus this plus this, the answer you get will be the smallest answer if you should decide to do these differences with any of these points here. That's what I'm saying. If you use this point 1,1 as your centroid, instead of using 1.75 and 1.5, you are using 1,1, 1,1 here also, 1,1 here also, 1,1. The answer you will get will still be bigger than the answer you get in this current summation that we have here. If you use 1,2 instead of 1,1, you do 1,2, 1,2 here, 1,2 here, the answer you get will be bigger than the one that we've already gotten when we use the centroid. If you use 2,1, the answer will be greater. If you use 3,2, the answer will be greater. That is exactly what we are talking. What I'm trying to explain. I don't know if this explanation has helped us. That's exactly what we say, what I'm trying to say when I mentioned the fact that the sum of squared. Sorry, hold on, guys. All right, please, sorry about that. So that's exactly what I mean when I say that the centroid gives the smallest sum of square distances. Please, does this help us understand what I've been trying to explain? Is hello? No, I just hope that we've understood by now what I'm trying to say. All right, thank you for the reactions. All right, back to our Jupyter notebook, and I think that's exactly what I tried to explain here. That is exactly what I've tried to explain. Okay, so and that will bring us into section 7, the k-means objective function, which is the objective function now is the within cluster sum of square. The mathematical definition, which we have seen earlier, is that given n data points, want to split k clusters C1 up to Ck with a centroid mu1 up to mu k, the within cluster sum of squares is given by this. We have discussed this already intensively in the class. And we've already explained each of the components of the function, so we don't have to waste time doing that again. So, but the goal of the k-means is to find the partition that minimizes this within cluster sums of square. This curly L rather represents within cluster sums of sum of squares. So let's see how to do that mathematically. I mean, using computational techniques. So in this case, we're setting up a small data set, 6 points, and then clearly 2 groups. So they're just 2 groups and 6 points. We want this data set to be group 1, 1, 1. We want 1.5, 2 to be in group 1. We want 2.0, 1.5 to be also in group 1. We want 6.6 and this to be in group 2, group 2, group 2. We've solved this manually in the class. If you remember, for those of you that were around, we did something very close to this. So that means our data set has 6 points and 2 features. When I run this code, you will see it here. So 6 points, 2 features. So this is point 1, point 2, point 3, point 4, up to point 6. Then the next step we would like to take here is to compute the within cluster sums of square for a given partition and the centroid. The math is that we take L to be the sum over K of the sum over I in Ck of this norm of the difference of each xi and the mu all raised power 2. So that's exactly what happened here. This code is a little bit long. That's because we started by we represent the cluster members in a list of labels. That is, I just took these labels as mp.array, label 0, 0, 0, 1, 1, 1. So 0 stands for cluster 0, and then 1 stands for cluster 1. Then I compute each clusters using k equals 2. I want to use 2 clusters. So we calculated the centroid using the mp.array, that is the mean of the first cluster, mean of x, that is label 0, that's when the first cluster would label 0, and the mean of the second cluster. So that will give us the two different means, and that forms, those will form the centroid for those clusters. Then we've printed, and I went ahead to print the cluster for mu1, and the centroid for mu1 and the centroid for mu2, by just picking the items, picking the points in that, the different coordinates in that coordinate. Now we compute the within cluster sums of square step by step using the for loop. I started by initializing the total within cluster sums of square as 0. Then for k equals range k, this is, I don't know, let me just explain this range k for those who may not understand what that is doing. So when you have range, if I say range of a number 5, this will give, if I execute this, it just give me like show that it's a range object 0 to 5. So when I say range of 5, that means I want it to give me numbers from 0 to 4. If I change this to list of range 5, you will see what's going to happen. It will give me a list of numbers from 0 to 4. Do you see it? 0, 1, 2, 3, 4. That is what range does. It gives you a list of number from 0 to 1 less the number in the range parameter. If I say range 10, it will give me from 9 to 0. You can see a list of numbers from 9 to 0. That's what range does. All right. If I want 10 to be included, I can say, give me a range from 0 to 11. If I want 10 to be included, then 10 will be included from 0 to 10. Do you see? So I can also do that in that way. So range is used to just write list of numbers from 0 to n minus 1. So if I say that for k in range k, what is k? K is 2. That is 2 clusters, right? K is 2. So if I say for k in range k, that means I just want to form 2 clusters, 0 and 1. Do you see it here? Cluster 0 and 1. I've already formed those clusters here. Cluster 0, 0, 0, and cluster 1, 1, 1. Please, am I communicating? So I'm saying for k, the small k represents clusters, then range capital K represents the number of clusters we have. Now, cluster points equal to k of labels equal to k. Of course, we've already selected label as 0 and 1, so it's going to pick 0, either 0 or 1. Then we were saying that let the mu, that is the centroid of k, be equal to centroid k. Then in this for loop, I have another nested for loop for x subscript I in the cluster points. We calculate the difference of each xi and the centroid. Then we took the square of the distance, the square of the distance, and we took the total within cluster sums of square, just mapping this. And when I execute this, you will see the answer. So the total within sums of square is 2. The cluster for mu1 is 1.5, 1.5. The centroid for mu2 is 6.5, 0. And this is a very simple Python code that helps us to calculate. That thing I just did manually in the whiteboard, that I was able to even complete the calculation. This is how to do it in Python. We've done it in Python to calculate the within clusters. And so wrapping the CW within cluster into a reusable function, instead of writing it again and again, if you want to calculate within cluster of any data point, you keep on writing this function. We can just put it in a function. So I created a function called compute WCSS. That is you can give it any matrix X, you can define labels that you want and the centroids that you want. So that means your function will take three parameters: the the matrix, labels, and centroids. And every other thing that we did here in this calculation was put inside a function. You start with k equals the length of the centroids. The WCSS will always be initiated to 0, the initialization. Then you use the first for loop and then the second nested for loop. You return WCSS. So once this particular function is registered in memory in Python, you can use it anywhere. So I've registered it by running that cell. So we can use it here by testing the function to know if it works, if the function works as expected. If I paste this here and execute it, you can see that the function has worked. I assign the function to a variable called WCSS underscore value, which is equal to compute WCSS. That's what we called the function. The function is called compute underscore WCSS. So in that function, we gave it our data point, which is the matrix X that we've defined earlier above, then the labels, and then the centroids. So we've defined labels and we've defined centroids. So this is the label, this is centroid. Centroid is defined here, and then labels are also defined here. And with that, we got the expected answer as expected, as we should. So when you look at the other part, so the question that I asked here is, what happens with a bad partition? Like what if you have a bad partition? Like for instance, we put a bad label as 0, 1, 0, 1, 0, 1. Like we are alternating the terrible split. So what's going to happen with that, our WCSS? So and then I put a bad centroid. The centroid is the mean of the X with the bad label is equals 0, and the mean of the X with the bad label is equals 1. So when you calculate this, you will notice that we will have so you notice that we have a very terrible partition. So this is the WCSS for a bad partition, which is 58.667. You can see how high this number is compared to the WCSS of a correct partition that is done. And for a good partition is better by, you can see the difference, 56.667. So what this is telling us is that when you start writing your code to classify or to split some functions into different, so yeah, as I was saying, we're able to, so this, with this experiment I just did, is just to help you see that it is important that when you are partitioning your data set, you do it in the right way. Because if you don't, you can see the difference. We have a difference of 56.67 between a bad partitioning and a good partitioning. So it's very important that you partition your data set very well when doing this. Yes, so I don't know if there are questions before I move on. If you have any questions, please bring up a question. We have less than 26 minutes to end this class. There are questions. I know some of us are tired already. Please forgive me. I just have to complete this. Any questions, please? All right, in the absence of questions, I think I'm doing a great job. Let's continue. Section 8. This is the K-means algorithm step by step. Yes, now that algorithm that we looked at in class the other day, we want to actually execute it here, following the step-by-step procedure. We are going to apply this the Lloyd's algorithm, that's the K-means algorithm, starting by initialization, repeat convection. What is that? Guys, 1 minute, please. Okay, so I'm back. People, can you hear me? Sorry, I just had to quickly check on something. Please, am I audible? Am I still audible? Okay. So, I want to, before I go into all of this, I want to state something, right? You see, all of these calculations and estimations we've been doing, right, from the beginning. This may not, the actual implementation when you start working with data set may not be as complex as it is right now, but we have to go through this route because we want us to understand what's happening under the hood. Thank God for Python packages and libraries. There are a lot of Python libraries that would help you to accomplish all of this, breaking into labels, group centroids. You don't have to do this. There are Python libraries in NumPy libraries in scikit-learn, a lot of them that has already taken care of this. Again, I just have to say this now because I can imagine what is going on in some people's mind. That's how on earth can I know all of this? How on earth? So again, it's not this difficult, right? So it might be looking strange to you if you are not used to Python programming language, but it's going to be better off when we start using those established or created packages and libraries in Python. Please, if what I said is kind of relieving to you, if it sounds relieving, please give me thumbs up. People are sleeping in my class, and I don't like it when people sleep in my class. Are we together? I want to be seeing those reactions so that.
Together.
Okay, thank you. I don't want to feel like I'm talking to my computer because the class is just too quiet. Thank you for the reactions and for the response. Okay, so but that doesn't mean that I would ignore these things I want to explain. I will still explain it because it's important that we know it. So when we want to implement the K-means algorithm, we've already discussed this in the class. Yeah, for those who are following, they will at least able to get one or two things. We start with this, the first step 0. That is the initialization step. We choose k data points at random as the starting centroids, and then use a larger, more interesting data set. What use more interesting data sets? I just have to set a random. I want to generate random numbers. That was what I wanted to do earlier, but I just thought I should use it. I guess this so that people don't get confused. Generate random numbers. Yes, someone's hands up. Ask your question. Oh, Nathaniel said, "Will this part be part of our test tomorrow?" Mr. Nathaniel. So the answer to that question, let's just first understand this first. So this is what I want to do. I want to set so that if I run this code here, because right now we are generating numbers randomly. I'm generating random integers between 20 random integers with a step size of 2 for the 3 data points. So I called it group 1, group 2, group 3. When I execute this, and let's see what group 1 looks like. 1. So sorry, it's not group underscore 1, it's group 1. So this is what group 1 looks like. It has 20 points. Group 1 has 20 points. Can we see how it looks like? So we have more data sets now. And so is this many because we've created it randomly? If I look at what group 2 looks like, so this is group 2, also 20 data points. And we can see how group 3 looks like. This group 3 has also 20 data points. So now that we've seen what group 1, 2, and 3, what they all look like, we can go ahead and get them stacked together. So I want to stack group 1, 2, and 3 together. And so I'm going to print it out. Let me just take it out here and show us how that's going to appear here. So this is how it looks. Let me just, in fact, let me show us what X looks like. So X, so This is how it looks like. We've stacked the 3 together. That means we have 60 points now. Group 1, 2, and 3 stacked together will give us 60. You can see how long the data set looks like now, right? Group 1, 2, and 3. So that means we have a shape of 60,2, that is 60 rows and 2 columns. Then the next thing is we are going to initialize our k equals 3 because we want to create 3 clusters. Then we randomly choose k indices from 0 to n minus 1. So n equals the x, the shape. We want to know the number of data points, which is going to be 60 actually. Then the initial indices here, we have random choice. I'm using random placements or decisions throughout this particular experiment. mp.random.choice, pick n numbers, one size to be k, and want the replacements to be false, because we are going to be having this as a static number of size of our clusters. Then the initial centroid that we pick. Yes, please ask a question. Mr. Samshidin, your hand is up. Ask a question, please.
Yes, sir. Please, what is between replace and force? Is it asterisk or what, sir?
You say what is between replace and false?
Yes, what symbol is this? Is it asterisk or what? Between replace and force?
This is k. Okay, no, it's equal to. It's equal to. Replace equal to false.
Okay.
Yes, replace equal to false. Yeah. So that means what we're saying is, because we're doing random choice, I'm doing a random, I'm making a choice randomly. So I want to add this parameter that when I make one choice, the second choice, should it be replaced with another random choice? Then I say false. No, don't replace it. So if I make a false choice, leave that first choice to be constant. I'll make another second choice. Don't alter it. Make a third choice. Don't alter it. That's why I said replace equals false. If I don't put this parameter in this particular code, what will happen is that as I'm making choices, right? If my first choice is 2, for instance, if my first choice is 2, when you run the code again, that first choice will change to 3. It will keep changing, because that's how random function works actually. But because I don't want it to be changing when I'm making my selections, that's the reason why I added this parameter as replace equals false. Then the initial centroid will be x of the initial indices dot copy. So I'm making a copy of it. That whenever you see dot copy, it means I want to keep the original indices. Don't forget that the indices are the choices that we've made. So x of these indices, then make a copy of it. I don't want to modify the original x that we've had already. Then run this prints, and then this is what's happening. You can see exactly what happened here. We have randomly chosen initial centroids indices as 43, 26, and 56. Then the initial centroids we've gotten are mu1 is 3.915, 5.329. mu2 is 5.323, 0.612. And mu3 is 3.060, 7.463. Those are what you've gotten. Then this is second step now. Step 2 is the assignment step. This is the initialization step. Step 2, assignment step. We want to now do the assignment for each point. So on this assignment step, we have to create a function for it. And the function will take 2 arguments. It will take the matrix and the centroids that we've evaluated here, these 3 centroids. So what it does is it picks n to be the number of points, that is x dot shape of 0, that is number of points. Of course, we should know what x dot shape would always show us. X dot shape is going to give us the size 6,2, and when I say x dot shape of 0, it gives me just 60, because it will give you the first point in that tuple. So that's exactly what's happening here. Then we take the k to be the length of the centroids. That is number of clusters we have. That is k. Then labels is going to be mp.zeros. So mp.zeros usually populate 0 everywhere. All right, let me quickly explain what MP dot zeros do. If I say MP dot zeros of 3 and I run this, you see, it gives me 0, 0, 0, 0, 0 in 3 places. If I say MP of zeros of 10, it give me 0 in 10 places in an array. So this MP dot 0 of n means whatever number of shape that we have gotten here, number of points, give me 60 zeros. So because our shape dot 0 is 60 in this case, that means what that MP dot 0 will do, give us 60 zeros just like this as an array, 60 zeros as an array. That's exactly what is going to happen right here. Then we are converting the data type to int, yeah, because here is giving us the data type as a float. All right, so if you do d type, you see it's going to give us float, or d type of this. D type of this is float. Actually 0 0.0, that is float, but we want it to be integers instead of 0 point. We want it to be just integer, so it store everything as just integer. Then our nested for loop. For I in the range n, we first calculate the distance of the zeros in the k places. Then for k in the range k, we calculate the difference between each ki and each xi and the centroid k. Then we took the sum of distance squared, the squared distance, and we assign it to a cluster with the smallest square distance. That's exactly what happened here. And then we return the labels. So this is the end of the function. This function I'll start defining from here. We define the function up to the end. So I will execute the function, and the code has been executed. So if I want to call this function, all I need to do is say assignment underscore step, and that's exactly what we've done here. We run the function, call it as labels equal to assignment underscore steps. We give it the matrix and the initial centroids, and then we print everything. So this is what's happening here. We have the cluster labels after assignments. In our case steps, and 50 points, which is 1 up to 50 times, then cluster size becomes cluster 0, 20 points, clustering that has happened. We have to now take an update step. So this update step, we also define a function and we update it. And then when I run this code now, you can see we have better number of clusters now. So these are the centroids before the update step. Here are the centroids before update step. And here are the centroids after update step. Then with this part of the code, it's going to complete the k-means algorithm. When I execute this, it has finally completed the k-means, divided the class, the data set into 3 groups, such that there were 6 iterations that were executed before we got this convergence. So for iteration 1, we have WCSS to be 541.8 and so on. The maximum central shift is 1.69. At iteration 2, the WCSS reduced to 406. At iteration 3, it reduced to 393. Iteration 4, 287, 5, 106, and 699. And here, you can check out the maximum central shift, 0. So at this point, there is no difference between the previous central shift and the next. That's why we conclude that convergence had happened after the 6th iteration. And that's the point where we got the number of clusters to be 3, and then we have the minimum, the least WCSS, which is 99.76. And this is the execution of the k-means clustering by you writing a function. Again, you will not be required to write these long functions. There is a k-means clustering what's it called, library, that I will introduce to us later. But this one will just help you to understand how it's being done should you have a need to write your code from start to finish. Yes, are there questions? Are there questions, please? Okay, so I'll stop here. I'll stop here, and I'm going to just in case you have not reviewed these practice questions, I would strongly recommend that you review the practice questions. They're very easy. Exercise 1 to calculate the Euclidean norm, the centroid, calculate centroid between points, know how to perform one iteration of the k-means by hand at least. This iteration is a very simple one. Then the elbow interpretation, elbow method. So yes, I think we've covered a lot, and what we've done, yeah, you should be able to go ahead and look at this notebook. Time will not permit us to come back to this notebook again. I think this is the only opportunity I have to explain this k-means by hand. The next time we're going to be running k-means, we'll be doing that with the libraries and the packages, and that will look much more friendlier than these ones. But for this, please just try to understand the concepts that we have explained here. All right, thank you very much. I'll take questions, then give instructions of how tomorrow is going to look like before we call it a day. Any questions? Is it Mr. or Mrs. Chukuno? So I don't know how to address you. Your mic is unmuted. Do you have a question for me? Okay, the mic has gone off. Yes, Mrs. Samuel, please go ahead.
Yeah, sorry, sir. I don't have any question. Sorry.
All right, that is fine. Mrs. Samuel, your hand is up. Please go ahead. Question.
Yeah, can you hear me, sir? Are you with me, sir?
I can hear you, please.
Okay,
Very
okay.
well, I'm with you.
The bottom line is that just as you said, personally, the analysis are not too cumbersome, but just that this particular what we did today, one need to take time and balance and go through it over and over again to get it properly. That is just my own contribution, sir.
Oh yes, I agree with you. Especially if you've missed all my classes and you've not gone through this notebook from before now. Yes, you need to go
The
over and
class
over it again.
I'll follow the class sequentially. I'm only referring to this today's problem. I won't need to really take his time and go through it. I'm only referring to today's problem.
Okay, that makes sense. No problem. Irene, I saw your hand up earlier. Do you still have a question or you've changed your mind?
I wanted to ask if what you taught today, since it's taking a bit for us to, or for me anyways, to catch up, because I was trying to use my phone to follow with Google Colab. It wasn't easy. So following
I
and
see.
practicing was not feasible for me.
I see.
Yeah.
Okay.
And also a
Okay.
question that I
I'll
had, I don't
respond
know
to
if you
that.
are a
Please go ahead. Go
question
ahead with
that
the
I
question.
have. In a case where you're trying to find the centroid,
Yeah.
you are given a set of like an array, but you are not given a partition. How do you know to partition it? That's my question.
Okay, if you are to calculate the centroid, you don't need partitioning for the centroid. If you are to calculate centroid, you are given a set of points. Just centroid is just depending on the
Sorry,
dimension. Yes.
you have to proceed further to now calculate within sum of squares, and not at a point to calculate in the one we did in class, there was something about C1, C2. Yes. So
Yes,
we're
these are the
given
clusters.
six
Yeah.
data points.
Yes,
The
please.
six, yes, six. And then it was now divided into three. So three
Yes.
each. So C1, C2. Then we
Mm-hmm.
now did the iterations for it.
Mm,
So I'm asking, in a
yeah.
case where perhaps you are now giving six, but you are not giving the
Mm-hmm.
partitioning, how do you
Mm.
know to go about it? Is my question.
Okay. So I won't answer that question now, because we are still going to touch on that. But what I want to say is that we will not, although I've introduced one way of knowing how to number of partitions, that is the L2 method. Of course, but we've not done an exam calculating example on that. So there are other methods to use to partition, but one method is the L2 method, that you have to plot graph of the data points, and when you have the elbow at the point on the x-axis, yeah, you have the elbow. That's what to tell you how many number of partitions to create. But if you are asking this question because of your test tomorrow, be rest assured that you will not be given such kind of a problem to determine the number of partitions. I won't give that question, because I know I've not done a calculation, an example, a solved a worked example that explains that. Yeah. Does that make sense?
Yes, sir.
All right. Are there more questions before I would give my announcement? Class rep, do you have any question for me? Are you still on this call? Class rep. Class rep has left us out of this class. Okay, so let me give my announcement. So, like I said, it's important that we know how to. So, I understand that not everybody are very
I'm here, my
familiar
network.
or conversant with. Okay, class rep. Class rep is always in a place that have bad network. Maybe she's in Kefi. Kefi and bad network. So, I understand that not everyone has proficiency with Python. So I'm not going to take it very hard on everyone. I will take it very slow. But one thing I would recommend, highly recommend, that we master before tomorrow's test, especially for the computational part, is number one, how to represent matrices on array, how to calculate norm of vectors, how to calculate the norm of the difference of vectors, and how to perform this simple for loop that we did to calculate centroid. Yeah, those are the simple things that you need to know to be able to attempt my test for tomorrow. That is one. Then secondly, if you don't have a laptop, don't worry, you should be able to attempt the test with your phone. Yes, you should be able to attempt the test with your phone. The only thing that you will need internet to do that. I just hope and pray that the internet in Unsuk tomorrow will be better for us to use phones. So you can either use phone, or you can use yes, someone is asking, is that a note for this class? I think you must be a new person in my class. Yes, we have lecture notes, and the notes is in my you can access it from my website. So since you asked, let me quickly thank you so much for lectures. Yeah, let me quickly show you for this. Who asked that question again? Let me see the name again. It means today's your first day. Really,
He's
really
not a
grateful,
new
sir.
person. He's not a new
So why
person.
didn't you know that? Why didn't you know that there's a lecture notes? My question is that today's lecture is going to be part of our tomorrow's test. Thank you, sir. I will answer your question. Hold on. So when you visit this site, right? When you visit this site, you come to that is echnamdi.com. That's my personal website. Go to research. Then under research, you will see this course that I'm taking you, mathematical and computational techniques. There are other courses I take other students from other institutions. When you open that course, come to materials, you find it here. This is the lecture notes or the mathematical part of what we've been discussing. You can preview it. When you preview, you will see all the things we have spoken about. Everything we spoke about, they are here. Even the Python guys that we discussed, you can see the data metrics is already discussed. I have explained, and we've done all of this. You can also download it to your device. Then when you come to this guy, you find this guy here, right? You'll find the Jupyter notebook that I just explained to us. Download it from here and you can access it. So that's that about that. Yeah, so again, this is how the test will look like. Tomorrow there will be a class before the test. We'll have a class, at least the class will run for 30 minutes. After the class, there will be a test that will follow immediately, a written test that would have to do with calculation. Then immediately after the calculation test, another 30 minutes coding test will follow. The coding test can be done with your phone, like I said. It can be done with your phone. It can be done with your laptop. But you will need internet to access the test. So, class rep, are we meeting by 9 o'clock or 10 o'clock?
Okay, let's say we have another lecture. It's 9, no. So that we'll
9,
finish
okay.
up and go. Yes. We have another
9 is
lecture
fine.
by 11.
All right, 9 is fine. So 9 is fine. So when we meet by 9,